On the 12th day of Christmas, Mr. Ing gave to me 12 perfect scores, 11 lessons learning, 10 steps for factoring 9.
Hey guys, let's go dark mode. I'm on 4.43, analyze the graph of a square root. All right, let's take a look at these questions. Blood donation. Get a pencil here. When blood is donated, medical professionals use a centrifuge to separate this thing that spins in a circle. The centrifuge spins the blood, causing it to separate into three components, which are red, platelets, and plasma. In order to efficiently separate the blood, the centrifuge must spin at a specific rate measured in rotations per minute, RPMs. It's kind of like your car. For the required gravitational force, G-force, or exerted on the blood. For a centrifuge with a radius of 7.8 centimeters, the RPM setting of a centrifuge is determined by the product of 143 and the square root of G-force required. Part A. So let's go ahead and write an equation, complete the table. So it's telling us to let G represent the force and R represents RPMs. So the centrifuge, the RPM of the centrifuge has a radius. So this is going to be my just in pink. That's going to be my R. R is equal to 143. Maybe we should make it white or something. 104.23. And then the word product is multiplication. And then the square root of the G-force. So that's just going to be square root of G. So you're just putting out math symbols here, okay? Now, how do I make a graph? Let's go ahead and just draw a chart here. Okay, normally we write X's and Y's, but your Y is over here and your X is normally over here. So I want you to write R and then your G. Okay, so with this equation now, R equals 104.23 times square root of G. This is what we're going to be using here. Okay, so if I put in, say, 0 in here, the square root of 0 is 0, and 0 times anything, or 0 times 104.23 is also going to equal 0. Okay, so if I put in 1 in here, the square root of 1 is 1. 1 times 104.23. I guess that should be in pink. Okay, let's pick some bigger numbers now. Let's say I put in 400. The square root of 400 is 20, and 20 times 104.23 is going to give me 2,085. Okay, you can just copy these numbers down. You can put that in your calculator, which I can show you. And the reason I'm picking these numbers by 400s is they've given me a graph. So if you notice, there's 400, 800. They're just counting by 400s there. So I have 1200. This will get me 3611. And 1600 is 4,169. Okay, let's go ahead and try to graph that. Do you want all these colors to be pink? We could do that, pink. There you go. Looks kind of funny, but it's okay. All right, let's go ahead and graph these. So 0, 0. And then 1, 100. So maybe like up there. So then 400. 2,085, so just past 2,000. 1,200. No, 400, so 800. Here now at 2,900, so right below 3,000. Okay. 1,200. 36, so past 3,500, and then 1,600. 4,169. Go ahead and sketch that. And your graph looks something like this. Okay? Okay, let's go now to that was part A, writing and graphing the equation. Let's now describe it. So the domain goes left to right. And you're starting at 0. And you're going towards positive infinity. So that would be interval notation. Domain 0 to positive infinity. If you wanted to write that with set builder notation, that would be for the value for the variable g in the set, that g must be greater than 0. How did I get that? The graph is going towards the right. So force is the variable g, which is like our x-axis. G, x-axis. Good thing it didn't erase everything, but in the set of g, g is greater than or equal to 0 into our set. Okay? All right, range. Range is bottom to top. Bottom to top. Okay? So I start here at 0, and then the last thing you're going to touch is that arrow as well. So let's keep going up. So you can write in interval notation, and it's pretty much the same thing, but no longer g, you're going to use r. In the set for r, for all values of r, that's greater than or equal to 0. Okay? Okay, how about these other ones now? Now it's going to ask us for an x-intercept. So our x-intercept would be 0, and it's still at the origin because you have the order pairs there. So that would also be 0. Okay, so the next one is the word increasing. That's just another way of saying the graph is going from left to right. What happens to our graph? Kind of like slope. So that's why it's increasing. It is positive because your g values are greater than 0. So we're going towards the right. Same idea. And notice how I put the x down here. So as x is going towards positive infinity, so towards this direction, so as it goes towards the right, that's essentially what this sentence means. What happens to the y values? So you could say as g goes towards positive infinity, what's happening? I would say that the r values are also going to positive infinity or up. So as you go to the right, it's going up. Okay? All right. Let's go now to our next example. Reflexes. Rachel and Ashley are testing one another on each other's reflexes. Rachel drops a ruler from a given height so that it falls between Ashley's thumb and index finger. Ashley tries to catch the ruler before it falls. The time, t, so time, in seconds required to catch the ruler is, that's equals, so let's say y equals the product. So you're going to multiply 1/4. So let's write that. Y is equal to 1/4 times the product of the square root of the distance. So distance is d. Okay, so let's just change the y now to t. So I have t equals 1/4. That is my equation. So let's go ahead and graph it, and then we can get the key features and then answer this question, okay? So let's put out here a table of values. Okay, if I put in 0, what happens to my t? Well, my t, d, so I'm putting it in here. 0 squared is 0. 0 times anything is 0. Okay, now if I put in 1, square root of 1 is 1. 1 times 1/4 is 1/4. Whoops, that's supposed to be pink. I'll change them all later. Okay, so if you put in, okay, pay attention. I'm putting in now 4. I skipped 2 and 3 because I went perfect square. So 4 is a perfect square. Y square root of 4 is 2. 2 times 1/4 is 2/4 or 1/2. If I do 9, square root of 9 is 3. 3 times 1/4 is 3/4. And 16, let me show you guys by step. Square root of 16 times 1/4. And then you'll get 1 right there. Okay, let's go ahead and change all these to pink. Okay, so let's go ahead and graph that. Okay, 0, 0. 1 and 1/4. So you notice there's 4 boxes. 1/4, 2/4, 4/4. 1, 2, 3, 4/4. Okay, so 1 and 1, 4 and 2/4, so 1/2, 9 and 3/4. Okay, and then that's our graph. Okay. Let's go ahead and look at our key features just like we did in the previous step there. Let's go ahead and get the domain, range. They're all going to be the same. Increasing, positive, because as I go from left to right, domain is 0 to infinity. And the answers are also going to go from bottom to top, 0 to infinity. Okay, this part's going to be new. Graph the parent function. So the parent function is just the square root of d. Okay, so let's say you do t is 1. I'm going to call this one t2. What happens to our time? Well, we're not going to multiply by 1/4. I'm just doing the blue box. So square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3, square root of 16, putting up here, is 4. So then if you graph that, the white and the blue, so I got 0, 0, 1, 1, 4, 2, and then 9/3 is way up there. Okay, so your graph looks like this. Okay, so the question is, let's get a different color here. Oh, I like the yellow. What is happening to this graph? You're going from the original to the blue to this, it's not yellow, it's orange. What's happening here is it's being compressed, pushed down, compressed vertically. So notice my arrows are pointing down. So that describes what's happening. Okay? Okay, question number 20. Let's talk about racing. A race car is moving along a circular track, experiences inward acceleration that is dependent on the velocity of the car. The velocity, so V for velocity, in meters per second. So if you look at your graph, meters per second, that is V. V is down here on this axis, okay? Per second is given by the product is, that's equals, the product of 17 and the square root of acceleration. Square root of acceleration, okay? Whoops, that's not V, there's V, there's A. So let's erase this one. Okay, so this is what helps me if you ever forget. This is your x-axis, that's your y. So when you're making your table of values, I would just do something like this, x, y, and then put back your letters, right? This is normally y, this is normally x. So we're gonna say that our acceleration, whoa, it's moving. A, why is it moving? Oh, I know why. And that's our V. Okay, so if I put in 0 into this equation up here, square root of 0 is 0, 0 times 17 is still 0. If I put in 1, square root of 1 is 1, 1 times 17 is 17. if I put in, okay, I'm not going to put in 2 or 3. I'm going to put 4 because I get the square root. Square root of 4 is 2. 2 times 17 is 34. Square root of 9 is 3. 3 times 17 is 51. And let's put in 16. Square root of 16 is 4. 4 times 17 is 68. Okay, so let's go ahead and graph this. 0, 0, 1, 17, 4, 34, 9, 51, and 16, 68. Okay. Let's get a graph here. Okay, so that is our original. So how can this compare to the parent graph? So the parent graph, again, would just be this one in pink. So let's call this V2, the velocity of 2. So you put in 0 for x, you get 0. 1 is square root of 1 is 1. Square root of 4 is 2, 3, and 4. Okay, so let's go ahead and graph that. It's going to be super small. 0, 0, 1, 1, 4, 2, 9, 3, and 16, 4. So my graph's going to be like this. So how do you get this graph? Well, if you can figure what's happening, you're starting from the parent graph, the orange graph, pink graph, let's call this pink graph. And then you're pushing it up to the parent graph. Okay, so the pink is the original parent graph to the kids. Well, this person's really, we can say, stretched vertically. Stretched vertically is what was happening. Okay. All right, let's go over question number 21, distance. Larez is standing in the side of the road watching a cyclist. So let's see what kind of cyclist he has here. Watching someone, that's my bike, they're laughing at me. Okay, the distance, so D for distance, between Larez and the cyclist is a function of time and given by, so D is equal to the square root of the sum, so that's the addition, sum of 9, so plus 9, and the product of 36 and the time squared. So that's what our equation looks like. Okay, so we just wrote a graph. Let's go ahead and graph this now. Okay, so the easiest ones to always pick is just, I like to do x, y, normally the y is out here, so the x is in the inside, so you have d, and then t. Always put in 0, so 0 for t, so 0 squared is 0. 0 times 36 is 0, and 0 plus 9 is 9. Square root of 9 is 3. Okay, let's put in 1. 1 squared is 1. 1 times 36 is 36. Pay attention, it's 9 plus 36, which is 45. So the square root of 45, if you put in your calculator, right, it's below square root of 49, which would have been 7. So let me put that in my calculator. 45 squared is approximately like 6.7. Now if I put in 2, 9 plus 36 times 2 squared, so that gives me 36 times 4. Then add the 9. So square root of 153. Gives you about 12.4. Okay, let's go ahead and graph that. So on the x-axis, y-axis, I have t for time, measured in seconds. Maybe you're going up to 2 seconds. So 1, 2. And then over here you have d, which is the distance, and that is measured in feet. And I go up to 13. And I cut it in half, so that's like 6.5, 2, 4, made it 6, 7, 6, 8, 10, 12, something like that. So let's just graph it. All right, 0, 3, 2, 4, 6. I mean, you can just count by ones or something. So the big idea is that one is 3, and then it's 1 and 6.7, and then 12.4. So it's going up pretty fast. Okay, and then we just do the same, describe key features. So we have domain, range, and if it's increasing and it's positive, right? So the domain is all the x values. So you're starting on the x-axis here at 0. So for the time, you can only start at time 0, but then you can go all the way to keep going, and you can go basically to infinity. And then the range is the same thing, right? Oops. Remember, with infinity, you always have a parentheses. The range is bottom to the top. So you're coming from down here, but pay attention. The range is only starting at that number where I just hit there on the y-axis. So that would be 3 to infinity. Okay? So those are our word problems involving the square root function.
Rudolph the statistician, simple data everywhere, me nights and heart conditions, calculated with great care, when all of his population gathered from coast to coast, sought out his information, he would always give the most. Then one foggy Christmas Eve, Santa came to say, Rudolph, with your pencil write what gifts I should take tonight. Quickly he pulled the children